Hi, my name is Luna Zhu, and this is the presentation for ECE 535 Summer 2022 demo project. My partner Prit Patel and I made an audio speaker to demonstrate concepts we have learned in class. Speakers undergo a series of energy conversion through magnetic fields generated by magnet and coils attracting and repelling each other. Electrical energy converts to mechanical energy and moves the diaphragm of the speaker. This movement pushes sound waves to eardrums, and then they are translated as sound by brains. One of the magnetic fields involved is from current flowing through the coil. This can be explained by Beelzebub's law, which states that a current flowing through a conductor produces a magnetic field. Since the coils are like solenoids, Ampere's law can be used to approximate the magnetic fields produced by the coils with a simpler math model. An example calculation using Ampere's law will be presented in the next slide. Here's the magnetic field calculation for the model we have using Ampere's law. The turns in the coil is 38 turns, mu is the permeability of free space, and the current from a phone auto jack is 1.3 milliamps. With the formula B equals to mu times the turn per unit length ratio times I, the magnetic field the coil generated is about 2.4831 microtesla. Here's the list of materials we used to make the model. Different magnets and diaphragm materials were used for trials of the demo. We'll see all the demonstrations in the video on next slide.
Here we've created our demonstration for the audio speaker. Starting from here, we have the audio jack connected to the original audio source of sound. We have two wires coming in from this initial cable that are attached with alligator clips to this wire right here. This is exposed with a lighter from the coating that was on top of it originally, of the magnet wire. The magnet wire is then wrapped around this tube, and then that's connected to this cone above here. In our case, that's a bowl, and in a different experiment will be something else like a a cup. And then below that, we have two neodymium magnets as our source for our permanent magnet. And so I'll go ahead and let the music play to see the experiment number 1 with two neodymium magnets and a bowl. Now, to add experiment number 2, we'll add these 4 smaller magnets, not neodymium, just arts and crafts magnets from the regular store, into this pile. And so we now have 2 neodymium magnets and 4 of these arts and crafts magnets. And we will do the same experiment, the same trial. Here's the final of the 3 trials where we've replaced the bowl with a cup. We're still using the 2 neodymium magnets. And I'll go ahead and start this. As we can see, we've completed all 3 trials, and we've gotten results in terms of audio decibel levels for all of these 3 sounds, and we'll record those through graphs on the next slides.
In the figures, we can see that after playing the same music, the peak decibel level was highest for the cup with 2 neodymium magnets and lowest for the bowl with 2 neodymium magnets. However, there was not much difference created with the addition of the craft magnet. This is consistent with the variables that are referenced in Beelzebub's law and Ampere's law equations. In conclusion, this speaker demo successfully worked with a few different parameters and is a successful practical application of electromagnetic principles we learned in class.